Hello, so in this video we're going to look at the idea of integration as the idea of finding the area between a curve and the x-axis. So in this case we've been tasked to find the area of the region which is bounded by this curve, the y equals x cubed minus 9x, and the x-axis. So I've got a sketch of y equals x cubed minus 9x on the right hand side, and I want to find the region in here and the region down here, and I want to add those two regions together. So in fact, I'm going to call this region R1 for region 1, and I'm going to call this region R2 for region 2. Okay, so let's have a look at this. Well, first of all, I need to find the bounds of my regions. So in other words, I need to find where this curve goes through the x-axis. So in order to do that, I just set y to be 0, because of course the line, the x-axis, is just a line y equals 0. So in order to find the bounds, I do x cubed minus 9x equals 0. And okay, if I factorize this, I get x times x squared minus 9 equals 0. And if I factorize, so x times by x minus 3, x plus 3, because of course the x squared minus 9 is just difference of two squares. So therefore I find that x is equal to 0, or x is equal to negative 3, or x is equal to 3. So there we go. So those are my three bounds. So this is negative 3, this is 0, and this is 3. These are the 3 points which go where the curve goes through the x-axis. So now I can actually find the area of each region. So let's first of all find the area of region 1. Okay, so let's find the area of region 1 first of all. So I'm going to do that by integrating. Now I need to be careful about my limits here. So my limits are always the leftmost bound to the upmost bound, and that's the upper bound. Okay, so my lower bound in this case is negative 3, which is on the left. My upper bound in this case is 0, which is on the right. And I'm going to take my x cubed minus 9x, and I'm going to integrate this with respect to x. Okay, so let's actually figure out what this is equal to. Well, okay, let's first of all integrate this function. So I get x to the power 4, and I divide by that power. And then I integrate the x squared, and I divide by that power, so I get, I integrate the x, which is x squared, and I divide by that power to get negative 9 over 2 x squared. In this case, I'm going to put the plus c in just for practice. However, it isn't definite integral, so it doesn't matter about putting the plus c in this case. So I just make sure that I put my limits in as negative 3 and 0. Now just remember, when I put my limits in, all I need to do is stick 0 in first of all, so I get a quarter of 0 to the power 4 minus 9 over 2 times by 0 squared. Now knowing that my plus c will cancel later on with my negative c, I can just leave it like that. Then I take away, if I stick negative 3 in, I get a quarter of negative 3 to the power 4 minus 9 over 2 times negative 3 all squared. And again, my plus c is cancelled with the previous plus c in the other bracket. So if I stick all of that into my calculator, I find that comes out as 81 over 4. Okay, so in other words, the area of region 1 is equal to 81 over 4. Fantastic. Now all I need to do is go back and find the area of region 2, so the area of the blue region. Okay, well in this case it's a similar kind of idea. I'm still going to be integrating my curve, so x cubed minus 9x with respect to x. However, the bounds of my region, my lower bound is 0 and my upper bound is equal to 3. Okay, so my upper bound is equal to 3. So similar kind of process. First of all, I'm going to integrate this. Okay, so in fact I'm going to scooch this over on the right hand side just to give me a little bit more space. So the integration is exactly the same as before. So I get a quarter x to the power 4 minus 9 over 2 x to the power of 2, of course plus c, but this time my bounds or my limits are 0 and 3. Okay, so then if I stick in 3, I get a quarter of 3 to the power 4 minus 9 over 2 times by 3 squared. Of course, I know that my plus c is going to cancel with my negative c in the second bracket. Then I'm going to take that away from a quarter times by 0 to the power 4 minus 9 over 2 times by 0 squared, and again my plus c is cancelled with the previous c. So therefore this thing comes out as negative 81 over 4. Alright, so stick it all in the calculator. This region is negative 81 over 4. Now this is interesting. You notice that these two areas are exactly the same in value. They're exactly the same size area. However, one is positive. So my red region is positive, whereas my blue region is negative. Now you might be able to figure out why. Because my red region is above the axis and my blue region is below the axis. So if my region is above the axis, I know it comes out as positive by default from the way that I work it out. Whereas if my region is below the axis, it comes out as a negative value, okay? Now that might answer your question as to why I cannot just do the integration straight away, so from negative 3 to 3, because ultimately that's where the region is. It's from negative 3 to 3 if I think about it as one region of my curve, so x cubed minus 9x with respect to x. The reason being is because this thing, check it out if you don't believe me, comes out as 0, okay? Now the reason why that's the case is because it's effectively adding this region to this region. Well, of course, 81 over 4 plus negative 81 over 4 will come out as 0. So if you have this situation, it's always good to be able to visualize your curve. If you have this situation where you've got a region above the x-axis and a region below the x-axis, you must separate it out into two separate regions. So the region which is above the x-axis, the region which is below the x-axis, work out those two things separately. Then you can add it together at the end. So to say then, I'll just write it up here, that the total area of the shaded region, so the area which is bounded by both curves, is just going to be 81 over 4 times by 2, because it's just going to be this, and then I just need to make sure that I make this negative. Okay, so 81 over 4 times 2, which is going to be 81 over 2. Okay, so 81 over 2 will be your final answer there. So just make sure that's a really important point. You must make sure you visualize the curve. If you have regions above the x-axis and regions below the x-axis, you need to work out those two regions separately. Okay, so second question then, we need to find the region which is enclosed by y equals x and y equals x cubed. So have a look. I've got here the curve y equals x cubed, that's the kind of curvy curve, okay? And I've got the straight line y equals x. And I need to find the area of this region and the area of this region put together, okay? So similar kind of thing which I had in my last example, I need to be careful because the red region, which I'm going to name region 1, is below the x-axis, which means I'm expecting it to come out as negative. Whereas region 2, which is above the x-axis, is positive because it's above the x-axis. So I can't just simply find the area of these two things put together. Before I do that, however, I need to find the intersection points of the curve and the axis. Okay, sorry, the curve and the line y equals x. So y equals x cubed and y equals x, where are those two things the same? Okay, so in order to do that, I'm just going to set them equal to each other. So the intersection point is going to be when x cubed equal y equal x, okay? So in that case, I can just simply take away x from both sides. And if I factorize, I get x times by x squared minus 1 equals 0, which gives me x times by x minus 1 times by x plus 1 equals 0, which means I have 3 points where they intersect, so x equals 0. That's no surprise, that's in the origin position. I have x equals 1, okay, so that's the point over there. And I also have the point x equals negative 1, so this is the point down here. Okay, fantastic. So now I'm in a position where I can actually calculate these three regions. So let's first of all find the area of region 1. So the area of region 1 will quite simply be the integral. My lower bound is negative 1 and my upper bound is 0. And I need to be careful here because what am I actually integrating? Well, just remember, it's always the top curve take away the bottom curve. So in this case, my top curve is equal to, well, it's the x cubed curve. Okay, so I'm going to do x cubed. My bottom curve is equal to y equals x. Okay. Now it shouldn't matter too much because I can always go back and basically say, well, okay, if it comes out as positive and it comes out as negative, it's not an issue because I just know I need the positive value anyway. But always think it's the top curve take away the bottom curve. So x cubed take away x. So if I integrate this, okay, so I get the integral, I get 1 over 4 times x to the power 4 minus 1 over 2 times x to the power of 2 plus my constant integration just for good practice, even though I don't need it because it's a definite integral and I'm doing the limits between negative 1 and 0. So if I first of all stick in 0, I get a quarter of 0 to the power of 4 minus a half of 0 to the power of 2. And if I now go back and stick in negative 1 and subtract it, so I get a quarter of negative 1 to the power of 4 minus a half times by negative 1 to the power of 2. And you notice I'm not writing in the plus c because of course the plus c here will cancel with the plus c here because I'm taking away. Okay, so therefore if I stick all of that into a calculator, I get myself a quarter back. Okay, so nice and straightforward, just 0.25 or a quarter. So that's the area of region 1. Okay, so region 1 is equal to 1/4. Now you notice in this case that I was quite clever, and because I did the top curve take away the bottom curve, I made sure that my answer came out as positive. Okay, so if you're expecting a negative answer there, then you should have just done x take away x cubed instead of x cubed take away x. But I already dealt with that negative, so I just thought top curve, take away bottom curve. Okay, now let's go back and find the area of region 2. So if I go back and try and find the area of region 2 now, again, I'm still going to do the integral. In this case, my top curve is equal to x. My bottom curve is equal to x cubed. Just have a look inside the region, okay? That curve is on top of that curve there, okay? So therefore, in that case, I can just do the limits between 0 and 1. So leftmost limit, take away rightmost limit. And if I'd work this out, well, integral of x, that's equal to 1/2 x squared. Integral of negative x cubed, that's equal to negative 1/4 x to the power 4. Remember to put the plus c in just for good practice, between 0 and 1. Okay, so now if I stick in my 1, I get 1/2 of 1 squared minus 1/4 of 1 to the power 4. I'm going to realise the plus c cancels, I'm not going to worry about that anymore. And I'm going to take away, well, if I stick 0 in, I get 1/2 of 0 squared minus 1/4 of 0 to the power 4, like so. And if I stick all of that into my calculator, I get myself 1/4 back, okay? So you notice that in that case, I was just a little bit clever to make sure they were all positive or all negative just by doing my top curve, take away my bottom curve, but I get they're both equal to 1/4. Okay, fantastic. So therefore, if they're both equal to 1/4, it means that the total area should be equal to 1/4 plus 1/4, or 2 times 1/4 if you prefer, which is equal to 1/2. So the total area there in that case is equal to 1/2. So a few things to remember. When you're trying to find the area bounded between two curves, always make sure that you do the top curve, take away the bottom curve. So the top curve, in this case with the red region, was the x cubed curve, and the bottom curve was the y equals x curve, or in this case straight line, okay? Whereas for the blue region, the top curve was the one on top of the region, which is the y equals x, and the bottom curve was the y equals x cubed region, okay? So always do top take away bottom. That just makes sure that your answer comes out as positive or negative as you sort of plan. So in this case, I want both to be positive. So in that case, I just did top take away bottom. But also bear in mind, again, same kind of thing as before. If you have two regions, one region above the x-axis, one region below the x-axis, you must make sure that you work them out separately, because one region will come out as negative, one region will come out as positive, unless you're being careful, okay?